Okay, so today we're going to do about first principles. We're going to do first principles and how finding the derivative using first principles helps us. So from our previous video, I think it's this one, we already know that finding the derivative gives you the gradient function. So when you find the derivative of a function, you get the gradient function. But how do you exactly find the gradient function? So now, to find the gradient at one point, in this case, the point is xy, we draw a tangent at that point, and then find the gradient of that tangent. And the formula we use to hence is m is equal to change in y over change in x. And now before we continue, we also know that to find the value of y, if y is equal to f of x, y would be equal to f of x, and y1 would be equal to f of x1. Since putting the value of x here will give you its corresponding y value. And we will use these two relationships when finding the gradient function, or rather the derivative, using first principles. We assume that this distance over here, that we call h, approaches 0. H approaches 0, meaning the difference between x1 and x is very small, such that both points lie on the graph of y is equal to f of x. So moving on, we know about the relationship that y is equal to f of x and y1 is equal to f of x of 1. So doing f of a certain x value would give you its corresponding y value. But this would only hold true for one function. This is why h has to be very small, such that both points x1 and x lie on the same curve of y is equal to f of x. Furthermore, we know that x1 minus x is equal to h. So x1 is equal to x plus h. We will be using these relationships and calculating our gradient function. So m is equal to change in y, which is now f of x1, which is equal to x plus h. So f of x plus h minus the f of x over x, which is x, minus x1, which is x plus h. This can be simplified further to give us m is equal to the f of x plus h minus f of x over h. So now, you have to get the general formula, not the general formula, but to get the formula using first principles to calculate the gradient function, we'll have to do f prime of x, which is now the derivative of f of x, is equal to, first the limit as h approaches 0, since h is really small, it approaches 0, of f of x plus h minus f of x over h. And this will only hold true if h is not equal to 0. So the value of h theoretically should be somewhere like 0.00000, moving on 0.001. Something so small such that both points x1 and x lie on the same curve of y equals to f of x. One more thing, this is the formula for finding the derivative of a specific function using first principles. Okay, so now we have a specific function over here, and we have to find the derivative of this function using first principles. So first we write down the formula for first principles, which is f prime of x is equal to the limit as h approaches 0, f of x plus h minus f of x over h. Okay, this is our formula. So moving on, f prime of x is equal to the limit Don't forget to write the limit. Writing the limit is so important and essential. F of x plus h, meaning 3x plus h squared minus 3x squared over h is equal to the limit as h approaches 0. And if we expand h plus h squared, we get 3x squared plus 2xh plus h squared minus 3x squared over h. Now by multiplying every term in the bracket by 3, we get 3x squared plus 6xh plus 3h squared minus 3x squared over h. And we can immediately see that 3x squared and negative 3x squared cancel out, and h is a common term between these two. Always remember to factor h out in the numerator so it cancels out in the denominator. This is very important. So this will be equal to the limit as h approaches 0. If we factor h out, we get 6x plus 3h over h, and they cancel out to give us 6x plus h. But this is still when the limit of h approaches 0. But now if the limit is approaching 0, that means that h is 0. So we only let h be 0 in this final step. And if h is 0 in this final step, that will be 6x plus 0, which is equal to 6x. Hence the derivative of 3x squared using first principles is 6x. Thank you for watching our video. Please like and subscribe to our channel.